Problem 12 states, given the following graph in both graphical and adjacency list representation, select the resulting minimum spanning tree, given A as the origin vertex. So in a problem like this, you are given several solutions with the actual final graphs. I would ignore these as you approach this problem. Instead, what I would do is I would actually perform the minimum spanning tree algorithm, Prim's algorithm, and then figure out what the solution is afterwards. So when you're writing this out, the way to do this is you have all of your particular vertices, A, B, C, D, E, and F, and you have to have a weight and a parent. And we're also going to have a priority queue, which will allow us to investigate which one we want to do next. So we're going to start at A. So A has 4 outgoing edges to B, D, C, and F. Originally, all the weights of A, all of these are going to be initially infinity, and we're not going to have any parents. When we do this initially, we're going to say that B's weight is going to be 5, and its parent is going to be A. Then we say that D's parent is going to be A, and its weight is going to be 7. F has a parent of A and a weight of 9. And then C has a parent of A initially and a weight of 6. So now we put in the elements that we've encountered in the priority queue as we've encountered them by least weight. So it will be B, C, D, and F. And so we'll put these here, 5, 6, 7, and 9. So now we're going to investigate all the outgoing edges of B. B has 2 outgoing edges to D and E. So B's outgoing edge to D is 1. 1 is less than 7. So what we're going to do is we're going to replace D, and we'll say 1 and B. And it's also going to get updated here, and you'll see how this is going to affect our priority queue. B also has an outgoing edge to E of 7. E's current weight is infinity, so we're going to update this to 7, and we'll say that E's parent is B. So now that B is removed from our priority queue, we see that D now has a weight of 1, and E is going to have a weight of 7. So what's going to happen is we're going to put D1 at the top of the priority queue, and the order will be 7 here after 6, but before F with 9. So D has no outgoing edges. So that makes this portion of the algorithm, actually, I apologize, D has an outgoing edge to E, which is 2. E's current weight is 7, with B. So what we're going to do is we're going to replace 7 and B with 2 and D. And so now that's all the outgoing edges from D, so D is erased. And now E was updated to 2, so now E is going to be moving up in the priority queue. So now let's investigate all the outgoing edges from E. E has 1 outgoing edge, 3 to F. F's current weight is 9 in A. So we're going to replace 9 in A with 3 in E. So that's the only outgoing edge from E, so we're going to replace this. So now we have C in the priority queue. C has 2 outgoing edges, 4 to D and 5 to E. D's current weight is 1, so we don't want to change that. And E's weight is currently 2, so we're not going to change that either. Finally, we investigate F. F has no outgoing edges. So now we have our final representation of the graph. B and C has the parents of A. So we have B and C here. Those are in. D has a parent of B. So this edge is in here as well. E's parent is D, so this edge is in. And F's parent is E. And so whatever this graph looks like is going to be our final solution. So we see that doesn't match with A, doesn't match with B, doesn't match with C. And look at that, it matches with D. Therefore, the correct answer to the solution is D.